So in magnetism and matter, see, the first magnet was somewhere found in 600 BC. Okay, the first magnet, the place called Magnesia. The place called Magnesia. Now, the name of that was known as lodestone. Lodestone, also known as magnetite. Lodestone, also known as magnetite. Okay, so that's it. So what happened here is a magnet, it behaves. Okay, so first we'll discuss about the magnetism. See, Earth is behaving like a huge magnet. It has 0 degree latitude here, and this is known as geographic north, and this is known as geographic south. And this one is what magnetic south and magnetic north. Okay, and the angle between both of them is 11.3 degrees, something. So it is known as we have geographic meridian and magnetic meridian. Okay, 1 second.
सर देखो हम लोग तो
सर
वी वैल्यू योर एफर्ट्स बारिश में भीग के आए हम सर अनम्यूट करो सर अनम्यूट सर वी
Here,
one second sir, I'll call them.
Here it is, no. Landing is. So here we have, the 600, the first magnet was discovered somewhere in 600 BC in a place called Magnesia. And the name of the magnet is known as lodestone or magnetite. In the magnetism, first we have, Earth behaves like a huge magnet, and this is 0 degree latitude, this is geographic north, geographic south, magnetic south, and magnetic north. Very close to geographic north lies magnetic south, very close to geographic south lies magnetic north. The angle between both of them is 11.3 degrees. Okay, 11.3 degrees. Now, so here there are two meridians, geographic meridian and magnetic meridian. Okay, geographic meridian means the line or the plane which cuts geographic north and geographic south is known as geographic meridian. And the plane which cuts magnetic south and magnetic north is magnetic meridian. The angle between the geographic meridian and magnetic meridian is known as the dip or inclination that is removed from the syllabus. Okay, so only 11.3. Now when you suspend a magnetic field, okay, so we have geographic meridian and magnetic meridian. Geographic meridian and geographic meridian and magnetic meridian. Okay, two are there. Now,
I don't think so.
no. So we have here. The second is if you suspend a magnet field. Okay, if you suspend a magnet field like this. So what happens? The magnet, this is north and this is south. Okay. So what will happen? This will be pointing towards geographic north, and this will be pointing towards geographic south. Actually, why? Because very close to geographic north lies magnetic south, and very close to geographic south lies magnetic north. That is the only reason. Okay, in the book it is written in a different way. North seeking pole. The name is different. It will be, and if you take the textbook, we have raised this question with CBSE and NCERT. It is written like M here. So this is wrong. This is magnetic south and this is magnetic north. Keep this in the mind. Now, like poles repel and unlike poles attract each other. Okay. Like poles repel and unlike poles attract. Okay. Unlike poles attract each other. Here we have north and north repel, south and south they repel. Okay. And here north and south will attract each other. North and south will attract each other. We will finish off this today. Okay, it's a small lesson. We can finish it off today. The next one is what isolated poles never exist. Okay. Fourth point is isolated poles never exist. Isolated poles never exist. Okay, fifth point is what? Fifth point is they can be made from iron and alloys. Okay. So they can be made from iron and alloys. Okay. They can be made from iron and ores. Okay, these are the 5 points. Okay, so one is the Earth is acting like a huge magnet. What happened? Is taking.
Sir, look at
Sir, he's not taking orders.
Delete that first.
Which one?
This one.
this is the picture. Stop joking, show.
Give. Check this whether he deleted or not.
Delete kar.
Delete that and from the deleted pictures also.
It is, I won't say.
That's
Done? Okay, give it to me.
What?
Now,
Where is my memory?
it's completely dark. Huh?
what
Very-
I'm doing.
Sir,
Sir, we want to go, sir.
That's why we are.
Okay, we'll finish off this.
Sir,
After that,
finish first. so we
Okay,
can
move.
start
Just one.
taking part.
Okay.
उसको
get it,
बोलो
we'll
थोड़ा
like one
नीचे
more
नीचे.
Get one after that again we can.
Sir, he's not accepting orders earlier.
Wait 1 second.
That's right.
We'll go down and go.
Now see here.
Sir,
उसके पास
These are the total 5 points.
Hello, Mango.
After that we have
इसको
the,
लिखने दे बात.
the bar magnet. Okay. So suppose
ये तो बीमार हो जाएगा ना. बीमार. जाके नीचे ऐसे जाता है.
Yes.
Okay.
now see here.
जाके नीचे.
Now arrangement of the fillings. Suppose if you want to see the fillings, the arrangement. Arrangement of iron fillings. So what will happen? Suppose if you take on a paper. So it is like, you take a bar magnet, keep it down. You put some, take some iron fillings on the paper and you put the bar magnet below that. Okay. And then what will happen if you see this, we can see all the lines. Okay. Like you'll have the patterns like this. You can see the patterns like this. Okay. This is how the, it shows that, magnetic, there's a magnetic field around that means all the iron fillings will be arranged in the pattern. It shows that the magnetic field lines. Number 2, it cannot tell the direction of the magnetic field lines. After that, we have a similar pattern of iron fillings is observed around a current carrying solenoid. The same thing will happen if you are taking a solenoid also. If you are taking a solenoid also, what will happen? So then also the magnetic, it is here also it has the same thing. Okay. Here also it will be same. Okay. Now, next is the magnetic field lines. Magnetic field lines continuous closed loops. The tangent to the field lines at a given point represents the direction of the. Okay, we'll study about the magnetic field lines now. There are total 5 points. Magnetic field lines. So they are number 1. They are closed loops. Okay, closed loops. Number 2, The tangent drawn at a given point represents the direction of the magnetic field. So tangent drawn at any point represents the direction of the magnetic field. Number 3. Okay. Number 3, it is what? The larger the number of field line crossing, the stronger is the magnetic field. Large number of fields, large number of lines. Now, large number of lines, stronger will be the field. Okay. And fourth one is what? They do not intersect each other. Okay. Fourth one is they do not intersect. Fourth one is they do not intersect. Okay. These are the 4 points. Is that clear? The magnetic field lines, they are closed loops. The tangent drawn at a point will give the direction of the magnetic field. Larger the number of lines, stronger is the field. They do not intersect each other. Okay. So that is about, magnetism, and there's about the magnetic field lines. Okay. Clear with you all?
Yes, sir.
Okay. Then we'll go with the next one. Okay. So can I raise this one, this part? Can I raise
Yeah,
this?
sir. Yeah.
Then I will start with this. I'll go a little faster now. So now here for the magnetic solenoid bar magnet as an equivalent solenoid. The derivation is not there. Did they teach you the derivation? Bar magnet as an equivalent solenoid. Did they teach you, Dhruti, this thing?
Yeah, sir.
Okay, the derivation, the full derivation they taught you?
Yeah, sir. The derivation is coming, right?
The derivation, okay. And the next, there are 3 derivations, right, in this one?
But sir, they in the syllabus they've mentioned that it is qualitative treatment only, so only the formulas come.
Yeah, that's what I'm saying. So
The axial and equatorial
Yeah.
formula.
So only we will write only the axial and equatorial formula here. So for axial line, suppose the solenoid is acting like what is a solenoid? A long helical wire in the form of a helical wire whose length is much greater than the radius. Now that is it, and they are very closely spaced. L is the length, R is the radius. Okay. So what is the formula here? The axial line formula is what? B axial is equal to what? Mu 0 by 4 pi into 2m by r cube, or 2m by r cube. And B equatorial line, it is equal to what? Mu 0 by 4 pi into m by x cube or r cube. Okay, this is the formula for equatorial line. Now, so x cube. So therefore now we have the dipole for a. These are the 2 formulas what are given. Next is the dipole in a uniform magnetic field. The dipole in this is also qualitative treatment, right? The dipole in a uniform magnetic field. Uniform magnetic field.
Yeah, sir. That is also qualitative.
The same qualitative treatment, right? So it is only a
Yeah,
formula.
sir. This and the and when it is perpendicular to the axis, both of them are qualitative treatment.
Yeah. So here, what is the formula here? U is equal to what? U is equal to minus m dot b. U is equal to minus m dot b. So here, what happens here? Now theta is equal to what? Theta is equal to 0. If theta is equal to 0 degrees, what will happen? It is equal to um is equal to minus m dot b. If theta is equal to 90 degrees, what will happen? Um is equal to what? Um is equal to 0. And here theta is equal to 180 degrees. Um is equal to m dot b. So these are the 3 cases here in the energy. And tau is equal to what? The tau formula is m cross b. It is also written as tau is equal to mb sin theta. Tau is equal to mb sin theta. These are the things. Now,
So time period.
yeah, time period I will write, and the magnetic field also. Time period formula is T is equal to what? Time period formula is T is equal to 2 pi under root of I by mb. 1 second. So T is equal to 2 pi under root of So,
yeah,
okay.
double
Okay, T is equal to what? T is equal to T by under root of I by M. Next one is what? B is equal to what? The magnetic field B is equal to how much? 4 pi square I by M. This is the I by M T square. This is the formula for magnetic field. Okay. So there are 3 derivations here. The first derivation.
ये बात क्या है बाल पे
Is okay.
But again she got it. Bali ke baad. I mean,
Okay. Now see here.
You are the
bar magnet is an
yeah.
bar magnet as an equivalent solenoid. Here, this is a qualitative treatment is given to this. No derivation is not there. So axial line mu 0 by 4 pi Vm by x cube or r cube.
video.
And equatorial line is mu 0 by 4 pi mu 0 by 4 pi m by x. Okay, the dipole in a uniform magnetic field is given by u is equal to minus m dot b.
Yes.
And if there are 3 angles, if theta is equal to 0, 90 and 180. So here m dot b means mb cos theta. Okay, minus m into b cos theta. So what will happen now? So here
I don't know why there
minus m dot b 0 and plus m dot b.
Break
So
na.
it's equal to mb sin theta. T is equal to 2 pi under root of 5 by mb.
Yes.
It's a time period. Means when you suspend a magnet in the presence of magnetic field starts oscillating. So that is the time period. Time taken to complete one oscillation. That is said to be time period. And this is the magnetic field. Okay. So next one is magnetic field formula. Next is electrostatic analog that already we did in the previous chapter. I'm not going to go ahead with the same. Okay, so just I write for the torque formula. So magnetostatic analog is tau is equal to P cross E and energy is equal to U is equal to minus P dot E. Okay, minus P dot E. So here also for tau is equal to what? M cross B. And here U is equal to minus M dot B. This is the formula. Okay. Now,
So it's a little bit.
next is what? Magnetism and Matte. Is it clear?
What to do?
Now, last part is. See,
I
we
forgot
discussed
to
the-
very good.
listen,
You should have gone to best two. Mera this period you want to
these are magnetic field lines. There are four points. Okay, they form closed loops. They can be like, this will be related to the accession region. Accession region. So we have closed loops. They form closed loops and closed loop that like tangent is the tangent drawn at any point shows the direction of the magnetic field. Third one is larger the number of field lines, stronger is the field, and next is they do not intersect each other. Next, bar magnet as an equivalent solenoid, BA is equal to mu 0 by 4 pi into 2m by r cube. Here equatorial line B is equal to mu 0 by 4 pi into m by x. Clear? And the dipole in a uniform magnetic field formula is U is equal to minus m dot B, which is equal to minus mb cos theta. Clear?
Yes, sir.
And there are three angles here we have taken. After that, this is the time period, and this is the magnetic field, and this is a torque formula, and we energy formula for both of them. Now we'll go with Gauss law of magnetostatics. Okay, we'll go with Gauss law of magnetostatics. Gauss law is there in both. Okay, electrostatics and magnetostatics. So we have to study what is magnetic flux also. Now suppose these are the magnetic field lines. Okay, these are the magnetic field lines, and suppose this is the surface, and this is the normal. N cap is the normal, and theta is an angle made with the surface. Theta is an angle made with the surface. So what is the formula now? So the formula here is what? Tau is equal to the formula is
BA cos theta.
yeah, what is that? Phi is equal to
BA cos theta. Phi is
flux
equal to
formula
BA.
is phi is equal to B dot A or BA cos theta. Okay. What is theta? Theta is angle between B and N cap. Okay, B and N cap. Okay, and theta is so this is flux formula. What is magnetic flux? Magnetic field lines passing per unit cross section area.
Oh,
Magnetic
I
flux
don't
is
know for them.
that much you
magnetic
have.
flux is 5V. Magnetic field lines passing. Magnetic field
Oh,
lines.
sorry, that's something else.
Magnetic field lines passing per unit cross section area. Passing per unit cross section area. Cross section. That is said to be the flux. Okay, the formula for flux is given here. Now, next one is here what? Gauss law. Gauss law of magnetostatics. What it says? the net magnetic flux to any closed surface is 0. So Gauss law. So the net magnetic flux through any closed
पता नहीं क्या issue है वो, ये पूछा है फिर कुछ
any closed surface
वो देखिए
is 0.
पूरी भी में से
The net magnetic flux to any closed surface is 0. Okay. No. Clear? So next is what that magnetism. Please note down this, then we'll go ahead.
मेरा तो छोड़